Hello, everybody. My name is Rita Hijazi, and I'm a PhD student at Aix-Marseille University in France. And today I will present a part of my work on for the PhD. I'm working on a syntactic text simplification system that uses a semantic representation. So I will start by defining what is text simplification. Text simplification is the task of converting a text into another equivalent text, simpler one, without changing the meaning. So I have a text that contains some difficulties. The main goal of text simplification is to transform this text into simpler one without changing the main ideas. So the task was used as a pre-treatment task for NLP tasks like text summarization or text translation, and it can be used for reading aids, for example, for second language learners, or for people with that have some difficulties like dyslexia or aphasia. So it has been used in NLP tasks or in as a reading aid. And traditionally, two main tasks are used in text simplification. So we have lexical simplification. The main goal of lexical simplification is to recognize or to detect the complex terms or complex words, and to transform this or to replace these words with simpler equivalents. For example, the word metamorphosis will be transformed into a more simpler word that is transformation. So it's lexical simplification. And we have the syntactic simplification. The main goal is to transform we are working on the structure of the sentence. So when we have a subordination, coordinations, appositive clauses, relative clauses, the goal of syntactic simplification is to go from the sentences that contain that type of difficulties into sentences that are simpler, and they do not contain that type of complexity. So in my PhD, I'm working on syntactic simplification. I'm not working on lexical simplification. So the syntactic simplification is the task of simplifying the structure of the sentences, like, for example, transforming the passive voice into active voice, or to split the sentences, the coordination and the subordination. So here we have an example. So in the input, we have a long sentence. We have two structural complexity. We have a relative clause and a correlative clause. So the goal of syntactic simplification is to transform this sentence into three simpler sentences. So this is syntactic simplification, and it is my work. So I'm working on a system that can go from this sentence into two or more simpler sentences. So different approaches exist in automatic text simplification. If we take this sentence as input, we have long sentence with a coordination. We have a subject and two verbs. So subject, two verbs, and a coordination. the goal, the perfect simplification is to split this sentence and to delete the splitting boundary, the coordination, in order to have two simpler sentences, and to rewrite the shared element. So here we have the shared element, the judge, and we write it before the second verb, and to split the sentence into two sentences. That is the perfect simplification. So the existing approaches, if we take the syntax-based approaches, the first one, it didn't know, or it didn't recognize where is the splitting boundary. Here, the splitting boundary is and, but the system did not recognize the splitting boundary. So it splits in a place, in an incorrect place, and the second system, it splits in a right place, but it rewrite the shared element in a wrong way. So the shared element is the judge. Here, the system writes it as it. It's not it. It's or the judge or he. It's not it. So these are the main disadvantages of these approaches, that they do not capture the semantic argument. So they split in a wrong place. Another approach are machine learning approach. So they do not work on syntactic simplification, because the corpus that works on, we don't find the syntactic simplification or the splitting operations. So they are working only on lexical simplification. So here we don't have a syntactical simplification. So it works only on lexical simplification. So that's why people worked on an approach that uses semantic representation, because they said that semantic information are important in these tasks, because the semantic representation could capture the semantic argument. So when we have this predicate argument relation, we can capture the splitting boundaries and to rewrite the shared element. So they said that these operations of division and deletion of the unimportant information can be driven by semantics. So the division, when we have the predicate argument relation, we can know where is the splitting boundary and where is the shared element to rewrite it. And when the semantic information could know where is the information that are supplementary, that we can delete them. But when we did a research, we saw that semantic information are not only, if we use only the semantic information for text simplification, it's not enough. We need syntactic simplification. We need syntactic information. So syntactic information only, they are not enough, and semantic information are not enough. So we need the two information, so syntactic and semantic information. That's why we use something called semantic dependencies. In semantic dependencies, we have the structural or the syntax information. Here, for example, in this sentence, we have a appositive clause. Appositive clause is where we have a clause that adds some information about that subject. So we have the information about the structural construction, and we have that predicate, argument information. So in these types of semantic representation, we have both semantic and syntactic information. So what we do is to, for this sentence, we create what we call the DMRS, Dependency Minimal Recursion Semantics. That is a semantic dependencies. So we go from the sentence, we create the semantic dependency of it, and on this graph, we apply some transformation rules in order to have 2 or more subgraphs, and from these subgraphs, we do a generation step. So sentence, the graph here, and from here, we do some transformation, for example, delete some nodes, delete some links between the nodes, and from the obtained graph, we have 2 or more subgraphs, and when we apply generation step on these subgraphs, we have 2 or more sentences. So here is our pipeline of our system. So the sentence, the DMRS representation, the graph, some rules are applied on this graph, and then we have 2 or more here, 2 or more graph, the transformed graph, and then we apply the text generation step in order to have the simplified sentences. So usually we have more sentences that are more difficult than this one, but in order to have a clear or clean example, we used a simpler sentence. So we have this as input. We create the DMRS graph on using some parsing tools. We apply some transformation rules using a graph transformation tool in order to have 2 subgraphs. So here we have to delete the apposition in order to have notice is, and here we add the verb. So we delete the oppose node, the apposition node, and we add the verb. And then we change here with the links in order to have 2 different subgraphs, and then from the subgraphs we do the generation step. So it is the graph transformation, the graph rule. So here in this step, to pass from this to this, we have to apply some graph transformation rules. To do this, we use a graph transformation system. A graph transformation system, it's called GRU, graph rewriting system. We apply some rules on the graph in order to obtain 2 or more subgraphs. The rule is composed from the pattern, so we search for the subgraphs in order to transform it, and the comments. So what we want to do, so search for a node that is called apposition, delete this node, add some nodes, or change the places of some nodes. We did a evaluation on our system. So, and we compared our system with 2 other semantic-based text simplification. That the 2 systems used semantic representation. So we have that we found that our system performs on text simplification. Why? Because here with sentence splits, we do not have the best score. We have another system that performs more. So to see why it performs more, we saw that here is our system, No, it's the original one. Okay, I'm sorry, I forgot to put the output of my system. But here, if we see, we have too much points. So the DSS graphs is our system. The DSS system, the system which we are compared to, it splits everywhere. So it splits more, but it does not mean that it splits better. So we have, so the splitting point should be before and. So here it splits just to split. So we have, okay, we have more sentence splitting, but it does not mean that it splits better. So it splits more, but does not mean that it splits better. So here, we don't have correct, we have agrammatical sentences. So attaching it to the ball, it's not a correct sentence. They do not preserve the subject verb object order. And one of the disadvantages of this measure that count how much point or how much splitting point we have in the output. So here, this types of that type of evaluation tool that or metric, they just count how much points we have in this output, and if we have more points, so that means that the system splits more and better, and which is wrong. So we developed a syntactic simplification system for English based on semantic representation and mainly on semantic dependencies. We used NLP tools for parsing, for graph transformation, generation, etc., and visualization. And we saw that our system works, or it resolves more syntactic operations. Other systems just resolve coordination and relative clause. Our system resolves coordination, apposition, and subordination clause. And we show that our system has better scores on some metrics. It doesn't split more, but it splits better. So one of our perspectives are we are running right now a human evaluation in order to evaluate if these sentences are correct or no, and to have if the grammatical the sentences are grammatical, if the meaning is preserved, and if the output is really simple or not. And we will do the evaluation on a large corpus, because we work just on 360 sentences and it's not enough, so we need to do it on a larger corpus. Thank you.